Hello class, today we're going to be talking about matter, in particular the physical and chemical properties, physical and chemical changes, and mixtures in pure substances. By the end of this lesson you'll be able to distinguish between the physical properties and chemical properties of matter, classify changes of matter as either physical or chemical, explain the gas, liquid, and solid states in terms of particles, explain how the law of conservation of energy applies to changes of matter, and distinguish between a mixture and a pure substance. On this slide we have a few vocabulary words that you do need to know, so take a couple minutes and write them down. Alright, so now that you have your vocab words written down, let's kind of talk about what they mean in regards to chemistry. We said that matter is anything that has mass and takes up space. And we look at different properties to be able to tell what the matter is that we are dealing with or that we are about to use. So one of the types of properties we look at is the physical properties. And this is broken down into two different types. We have extensive properties and we have intensive properties. Extensive properties are going to be properties that depend upon the amount of matter that is present. So this is going to be things such as mass. It's going to be things such as volume. Another that we typically look at is length and the number of moles present. So number of moles present. So anything that depends on the amount that we have available to us. Intensive properties are going to be independent of the amount of material present. So we don't need to know how much is there to be able to find these different properties. So that's going to be properties like your melting point and your boiling point. So BP for boiling point, MP for melting point. Density does not depend on how much is there. Color is one that you don't have to tell how much is there. Whether it is malleable or ductile or even soluble, solubility is an intensive property. Magnetism is an intensive property. So anything that does not depend on how much that we have there is considered an intensive property. And a physical change is a change in matter that does not form a new substance. So this can happen in a couple different ways. One of these is changing its size and its shape. And one way that we can do this is by tearing, or you can grind or cut something so that its size and its shape are different than it was before, but it is still the same substance. Another physical change is known as a phase change, and a phase change is a change in the state of matter. So going from one state of matter to another state of matter. And a couple of these are melting. This is when a solid goes to a liquid. The reverse of that is freezing or solidifying. So when a liquid goes to a solid. You have boiling when a liquid goes to a gas, or you have condensing when a gas goes to a liquid. And then finally you have this really cool one called sublimation. And this is where a solid goes straight to a gas without first going to the liquid phase. And the opposite of sublimation is deposition, where the gas goes straight to the solid, also without going through the liquid phase. Here we have a generic phase change chart that shows the phase changes for each of the states of matter. It also shows you the triple point and the critical point, as well as the changes in pressure versus the changes in temperature and how that affects each of the states of matter. We will go in a little more depth on this in a later unit. Okay, so while physical properties help us determine what we can see about an object just based off its physical appearance or its physical attributes, chemical properties are properties that we can only observe during a chemical reaction. It describes the matter based on its ability to change into new matter with different properties. So examples of this are going to be the reactivity or the stability of the substance. So how it reacts with other substances, how stable it is by itself, what its half-life is going to be, things like that. Then we have toxicity, flammability, so two other things that we have seen on SDSs. Then we have heat of formation. So if it's a compound and when it's formed, is there heat given off or is heat absorbed? Then you have heat of combustion. So how much heat is given off if or when it combusts? And then finally, the types of bonds that are formed. Between other molecules of that same substance, other compounds, other elements, that sort of thing. So all of these properties we discover whenever there is a chemical reaction. A chemical reaction or a chemical change is when one or more substances are changed into new substances that have new and different properties. So there's a change in the chemical composition or the identity of the substance. And we have a few indicators that there has been a chemical reaction that has occurred. One of those indicators is a color change. We can also have a change in odor, a change in energy, and this can be in the form of either light energy, so sparks are given off, or heat energy, where heat is absorbed or heat is released. So there's a temperature change that you notice. And then finally, a new substance is being formed. And this can be in the form of any of the states of matter, a solid, a liquid, or a gas. So a solid being formed within a solution is called a precipitate. And then we have a liquid. And then finally, a gas can be produced. And you'll notice that by either a colored gas or you can see bubbles within the solution itself, and that is an indicator that gas has been released. Now, any of these indicators can be accompanied by any of the other indicators for you to be able to tell that there has been a chemical reaction or a chemical change that has occurred. Here are a few examples of chemical changes. Mixing an acid and a base creates a salt and water as its products. Iron, when it comes into contact with air, begins to rust. Wood burning is a combustion reaction, and all combustion reactions are a form of chemical changes. And then finally, digesting your food. Digestion is a form of decomposition, which is taking one substance and turning it into two or more other substances. Now, all of these have something in common. They either absorb or they release energy. Now, according to the law of conservation of energy, energy cannot be created nor destroyed. It can only be changed or transferred. So whenever we have these different chemical changes and chemical reactions, we must account for all energy that is lost or gained within the reaction. Here we have a Venn diagram of the different states of matter. Now you may want to copy this down because you can expect to see this information on either a quiz or a test. Solids are rigid, have a definite shape and definite volume, and the particles are close together. Like solids, liquids have a definite volume, however, they have an indefinite shape, and the particles slide past each other. Now, because solids and liquids have a definite volume, they are not able to be compressed. Gases, on the other hand, have an indefinite volume, an indefinite shape, and the particles are able to spread apart and move erratically about the area. Because of their indefinite volume, they are able to be compressed. In the hot pink, you see the different phase changes. Liquids to solids is freezing, solids to liquids is melting. Boiling is when you go from a liquid to a gas, and then condensing is from a gas to a liquid. Sublimation is from a solid to a gas, and gas to solid is deposition. Now don't forget about plasma. Plasma is similar to gases in that it has an indefinite shape and an indefinite volume, and the particles move erratically. However, plasma is high energy and deionized. So make sure that you have that information down somewhere. I really liked this chart in your book about mixtures and pure substances. Mixtures are a blend of two or more kinds of matter, each retaining their own identity and their own properties. A pure substance, on the other hand, is something that has a fixed composition. So if matter can be separated, it is considered a mixture. If it cannot be separated, it is considered a pure substance. There are two types of pure substances. We have compounds and we have elements. If the pure substance is something that can be decomposed by ordinary chemical means, it is a compound. Now, what do I mean by being decomposed by ordinary chemical means? I mean that it can be broken down further, but it has to be broken down by either combustion or by decomposition. We just have to take away the different bonds holding the compounds together. So water, H2O, is a compound of hydrogen and oxygen. Sodium chloride, which is table salt, is a compound of sodium ions and chlorine ions. Now, elements are already in their simplest, stablest form possible, so they cannot be broken down any further. Mixtures also have two types. You have homogeneous mixtures and you have heterogeneous mixtures. Homogeneous mixtures have a uniform composition, meaning that they have the same proportion of components throughout the mixture. So the examples are going to be air, salt water, sugar and water, stainless steel. Heterogeneous mixtures, on the other hand, if you take a sample and then you take another sample, the two samples are not going to have the same proportions. They're going to have different proportions because they are not a uniform composition. So examples are going to be granite, wood, blood. At any point, if you take some of your blood out, you're going to see different percentages of platelets and different percentages of red blood cells and white blood cells. So that is considered a heterogeneous mixture. Here is another great little chart for you to look at and copy down that shows you the different types of matter. So your pure substances in the form of elements and compounds, and your mixtures in the form of your homogeneous mixture and your heterogeneous mixtures. That's all we have for this evening. So by now you should be able to distinguish between the physical properties and chemical properties of matter, classify changes of matter as physical or chemical, explain the gas, liquid, and solid states in terms of particles, explain how the law of conservation of energy applies to changes of matter, and distinguish between a mixture and a pure substance. Now, if you will do me a favor and go to the Google Forms page on the announcements on My Big Campus and just leave me a quick comment about what you thought of this lecture. All comments will be anonymous, so there's no worries there. I do want to make sure that I improve upon these for you. I hope y'all have a good evening and I hope y'all enjoyed it. Have a good night.